hundredths. There you go. That's the correct answer. Very good. Any questions or thoughts on that before we move on? I'll take your silence as no. We're all good. Um,
Yeah, thank you.
okay. So the next one here is a rewrite. So let me I don't know. Like it's almost like I have to give you the answer here, but let's say it's 4. Oh, that's not a good number. Let's go 5 to the minus 3 equals 1 over 125. So this would end up being the log base 5 of 125 equals -3. Okay, so this number is the base. This is what you're taking the log of, and this is the result or the right-hand side. So maybe you can use that to map what goes in positions, we'll call it A, B, and C.
So would it be log base 8 and then of 1 over 64 equals -2?
Yes. Perfect. Very good. Let's go to the next one here. This is going the other direction. So I'll make a similar one up here. Let's say it's log base 2 of y equals 3. Ends up being 2 to the 3 equals y. So this is the base. This is the exponent. And this is the result or the right-hand side. Maybe that helps.
Would it be 4 raised to 3 equals x?
No, you don't. Okay. So sometimes they actually want a number. I guess this is just the standard rewrite problem here. Okay. Um, so gosh, there's like so much that goes into these. So the first one here, log of 1, 2, 3, 4, 5 power of x. The 10,000 is really 10 to the power of 4, 4 zeros, 10 to the power of 4. Is that okay?
Yeah.
All right, so then this becomes log 10 to the 4 to the power of x, like that. You're just rewriting 10,000 as 10 to the 4 power. And then when you have an exponent to an exponent, as you have here, you can make it log 10 to the 4x. You end up multiplying.
Okay.
And then you can actually bring that out in front. So it becomes 4x times log of 10. Is that okay?
Yeah.
So now log is really log base 10. So whenever you have the same base as the thing you're taking the log of, it equals 1. So this part equals 1. It's 4x times 1, which is just 4x as your final answer. Any questions about anything we did there before we move on?
No.
All right, so e to the natural log of u represents like anything in parentheses, it becomes just the u. So the ln and the e undo each other. This becomes just x plus 2. that okay?
Yeah.
There's a lot of properties to remember for this, so it's easy to not understand exactly why this is working. Okay, now would you typically be allowed to use a graphing calculator on this? I think it said no calculator, but I mean that's kind of like you
Um,
could, you could.
I am not sure
Okay,
on this one.
because one of the ways to do this is to graph y equals 4 to the x, and then graph each of these until you get one that matches, that goes right and then up. Now, the 1 unit up is probably the one that's the easiest to sort of distinguish here. I think that's how you figured that out, maybe.
Yeah. Well, I
Maybe you just
accidentally clicked
or-
that. Yeah.
okay, maybe just real quick, because that's it. I mean, that's the rest of it. This is 4 units, right? But that's kind of the giveaway on that one. All right, we can move on to the next. So I guess you also, if you want any like problems, we're gonna get through this pretty quickly. I don't know how many there are, but we're not gonna need the whole lesson for this. So if you want us to pause and do more examples, please let me know.
Okay.
Okay, so f of 0, we're gonna actually start in reverse. So we're gonna start f of 3, here. That means to put 3 in for x. 3 minus 3 is 0. Minus 4 times 5 to the power of 0. 5 to the power of 0 is 1. Negative 4 times 1 is negative 4. Is that good?
Yes.
Now it gets harder. It gets more difficult from here. This is 1 minus 3 now. Negative 4 times 5 to the negative 2 power. Do you remember anything about negative exponents?
Not really.
Okay, so you end up flipping. It's really 5 over 1 inside parentheses here. So it ends up being 1/5 to the power of 2. And so what happens is most students just put that 2 on the bottom. It becomes 1 over 5 squared times the negative 4. 5 squared is 25, so this becomes negative 4 over 25. And I don't know, does it say anything about, it does say simplified fraction. All right, and then we'll do the last one here. F of 0, negative 4 times 5 to the 0 minus 3 power. So this becomes negative 4 times 5 to the negative 3 power. This becomes 1 over 5 to the power of 3. So basically that negative exponent, you make a fraction or you flip it, goes to the bottom. Negative 4 times 1 over 125, which becomes negative 4 over 125.
Can we do another one like that one?
Yeah. Maybe make it a little bit easier. Let's say it's negative 2 times 3 to the power of x minus 1. So let's start with f of 1. So f of 1 is negative 2 times 3 to the 1 minus 1 power. So see if you can take it from here. Like 1 minus 1, what is anything to the 0 power? And then you multiply by the negative 2.
Would it be f to the 1 equals negative 2?
Yeah, it's just negative 2. Yeah. Okay. So now we're going to do f of 0. f of 0. So this is -2 times 3 to the 0 minus 1 power. Just putting 0 in for x. This one's a bit more involved. It becomes -2 times 3 to the -1 power. So the negative exponents, this is the thing to remember here. It causes a reciprocal, a flip. Okay, so this becomes -2 times 1 over 3 to the power of 1, which is just -2/3. So the thing we're using here is that something to the negative exponent becomes 1 over x to the same exponent but positive. Okay, so let's do one more here. Let's do f of -1. That's -2 times 3 to the -1 minus 1 power. Why don't you try, see if you can make some sense of this.
Would it equal 2/9?
-2/9. Why would it be? Where does that? Yeah, does that they see how that negative comes from the original?
Yeah, I just did it.
Okay. All right, good. Okay. Yeah, so we got a few more problems here. Go. Assume we want to keep going on this. I'm struggling a little bit with like what they're asking for here. Maybe you can help here. It says here's a parent function 5 to the x. What are two parent points when graphing the function? So I mean, I like 0, x is 0, and then x is 1. What they're asking you to do is 5 to the 0 and then 5 to the 1 power. I mean, that's where you may know better than me.
Yeah, that's what looks familiar from class.
Okay. So then there's this next part where it says translate the function using the following transformations. Reflect over the y-axis, so that's the vertical. And then 2 units up. So the 2 units up is probably the easier, it becomes +2. I don't know how to say it, but the y-axis transformation is that x goes to -x. And that's an exponent. So it's a little weird, but it looks like it would look like this. F of x becomes 5 to the -x plus 2. Is that okay?
Yeah.
All right. Now I'm going to grab this table and then, so for the new coordinates, rather than well, there's two ways to do it. Like rather than recalculating them, you're supposed to use the transformations potentially. So what I'm trying to say here is that the reflection over the y-axis that affects the x value. You know, if you imagine like a point here going that way or a point here going the other way, that affects the x value, but not the y. So the smaller value here, like when it's 0, 0 doesn't change, but 1 goes to -1. And then the transformation 2 units up, each of these y values is going to go 2 units up. So 1 goes up to 3, 5 goes up to 7. Does that work?
Yeah.
Okay. Now, alternatively, you could put 0 in here and get 3, -1 in here to get 7. The equation of the asymptote is always the vertical transformation. So it's always y equals, and then what goes here is the vertical shift. So since you're going up 2 in your problem, it means you're putting 2 in there. The next problem is really similar. So I mean, different function, but like any questions on that before we run through it? All right. And yeah, I mean, this isn't going quite as fast as I thought, but you know, we're well on our way to finishing this, plus adding questions if we need to.
I actually do have a question on that one.
Yes. Yeah,
Because I just know on some of them it asks domain and range. I don't know if you can find or like what you would do with this
absolutely.
specifically.
Yeah, so if the original function 5 to the x, so the domain, and if you were to graph this, the graph is always helpful. The domain is all real numbers, minus infinity to infinity. The range is either the vertical asymptote to positive infinity, I'm sorry, the horizontal asymptote, or minus infinity to the horizontal asymptote. Okay, and you can see the horizontal asymptote is 0, and it goes up to infinity, it rises. So it depends on which way the graph goes. So the range in your problem is 0 to infinity. Now for the new function, the new f of x, which is 5 to the minus x plus 2. Again, a graph is really helpful here, but it's not necessary. Ends up looking like that. The domain is still all real numbers. It's always all real numbers. The range, though, is still the horizontal asymptote, which is 2 to positive infinity.
Thank you.
All right, so we got a new function here. So smaller value is 1, larger value is 3. You'll see why in a moment. Y equals log base 3 of 1. This is always 0. Log base b of 1 is always 0. That's a known, it's a thing to know. And then for the second one here, we talked about if the base is the same as the thing you're taking the log of, it's always 1. Log base b of b is always 1. All right. Any questions on that before we do the transformation?
Mm,
All right. So this time they give you the new function and they ask you like, what are the transformations? So you have to, and they actually even be more helpful. They're kind of nudging you in the direction of what they are. So the reflection here is this right here. And when it's out in front, that's over the x axis. It's considered a vertical transformation. The +1 is next. Do you remember if that's left or right?
left.
It's left, yeah. And then 2 units down. Okay, so now we're gonna modify points here. So I think it's kind of helpful to have the originals. I'm gonna grab this, and then we'll talk about the transformations. They're based on this. So x-axis affects the y value, left affects the x value, down affects the y. So let's get those new points here. All right, so the smaller x value. Okay, so the only thing affecting the x value is the left 1 unit. So these are each going left 1 unit. So 1 goes to 0 and 3 goes to 2. That's what's meant by left 1 unit. All right, and then the next one here for y, it's over the x-axis. So that negates the y and then down 2. The order matters. So you first negate the value and then go down 2. So 0 negated is still 0, down 2, subtract 2 is -2. 1 negated, and then down 2 becomes -3. And then we could maybe do domain and range on this if you would like, or talk about that or not. Up to you.
Yeah, why not? Let's go.
Okay. So again, really helps to know the graph here. So the original graph, log base 3 of x, looks like that. It's got a lot of, it's similar. The range this time is all real numbers instead of the domain. The domain, though, is the part inside parentheses has to be greater than 0. So it depends on, it's either what's called the vertical asymptote to infinity or minus infinity to the vertical asymptote. So it depends if it goes to the right. Well, that's not quite right. Not quite correct. So this one is the top one. It goes this direction. So we would say from 0 to infinity. Basically, you set this inside part greater than 0.
Okay.
And then the one that we transformed, which let's snip in here. Graph always help. A picture's worth 1,000 words. It's left 1 here, and then it's flipped down 2, but really all that does is it just kind of like makes it look like that. So the range is still minus infinity to infinity. The domain, though, it's moved left. It's from -1 to infinity. You still set this x plus 1, this part inside parentheses, greater than 0. Any questions on that?
No.
All right. Sometimes I'm not sure how much to snip in here so I can get some. Okay. What is the initial mass? They're asking you to find R of 0. 32 times 1/2 to the power of 0 over 300. So 0 over 300 is 0. It's like having nothing to share with a lot of people. They get nothing. Anything to 0 power is 1, so that becomes 32. All right, what's the mass after 900 years? Well, it's a long time. I don't know. I'll be around to figure that one out, but you're putting 900 in for T. So that 900 over 300 is 3. It's 32 over 1/2 to the power of 3. So that's think of that as 1/2 times 1/2 times 1/2. what does that become? What is what does this become when you multiply it? The
Is it 1 1/2?
You're multiplying. So you multiply the tops, multiply the bottoms.
3/8
You're
or what?
multiplying the tops.
One
Multiplying
eighth.
the tops. 1/8. Yeah. So it's 32 times 1/8, which is 4. All right. So the last question is easier done in a table. So in year zero, how much was there in year zero? What was the initial quantity we said for part A?
32.
32. So now 300 years later, that's its half-life. It's 16. 600 years, it's 8. 900 years, it's 4, and so on. How long does it take to reach 16 grams?
300.
300, yeah. And you can solve it using, some other things, but you can also just kind of recognize that that's what it is. Okay. We're on to number 10. 10 is definitely a calculator question. We'll do this. All right, so total of $2,000 invested in account, interest rate of 1.5%. Find the balance after 12 years compounded monthly. So we did this formula earlier. Can you tell me the value of P? What's the amount that they're starting with?
2,000.
2,000. And then the interest rate, it's shown as a percent. Can you convert that to a decimal?
Um, 0.015.
Yes. And then monthly is 12 for N, and then it's 12 years. So grab a calculator or use that one I recommended and see what you come up with, please.
I got 2,394.165592.
Okay, so it's money, so you go to 2 decimal places, make sure you round correctly. All right, the next part is something that is unrealistic, but that is what they do in some of these books, kind of like the 500 bananas that you buy from a store continuously. So money is never compounded continuously, but that is what they're asking you to do here. So it's a really similar formula. It's P is 2000, E is a function, and T is 12. Have you seen this E before? Is that familiar to you?
Yeah, a little bit.
All right. So it is in that calculator. You can actually just type E and then an exponent. And your result should be fairly close to the other one. Like it's not going to be super far off. So make sure you round to 2 decimal places when you give me your answer for that, please.
2,323 and 67.
The number you gave me is kind of far away from this one. It should be really, really close. Check
I
check
didn't,
the
I didn't times it by 12. Is it 12,099?
this has got to be in parentheses here. Let me and the reason I'm making you do this is because that is the hardest part is trying to figure out how to put in the calculator. This is what it looks like.
Okay, I got it. 2,394 and then 43.43.
Good, really good. Okay, on to another question here. Right, log base blank of blank. Uh, this is really find the x-intercept. Okay, so the x-intercept is when you set this equal to 0. So when you do that, and let's just for a moment presume you move this to the 2 to the x minus 3 to the other side of the equation. You have 2 to the x minus 3 equal 5. Then you would take the log of both sides. You'd end up taking the log base 2 of 2 to the x minus 3 equals log base 2 of 5. Have you seen that in class?
Yeah.
Okay, so on the left, it undoes the log, undoes the exponent, so it becomes just x minus 3 equals log base 2 of 5, and then you add 3 to both sides. So your x ends up being log base 2 of 5 plus 3, and now you've got everything. It's the base 2 of 5 plus 3, which is kind of weird the way that, like, I understand what they're doing, but it's hard to it's weird to enter it this way.
And then
All right, so that, go ahead.
this one also has it just cut off when I sent it to
Yeah.
you as x approaches negative infinity, what does y approach? And then as x approaches positive infinity.
Right. So you need a graph of this. Now 2 to the x looks like this. That's the parent function. And so we're gonna modify from that. So the minus 3 moves it left 3. Sorry, right 3. Then the negative flips it over the axis, and then the plus 5 moves it up 5. So your net result here and is that it's maybe I'll just highlight it. The net result is this graph right here. That's kind of your graph. Okay. So now we can do the end behavior, which is what you're looking for here. So as you go to the left forever, this approaches the horizontal asymptote, which is y equals 5. So as you go left forever, you can see it approaches the value of 5. The bottom one is to the right forever. So if you're going down, how far down does this go to the right? What's one way we could describe that?
Negative infinity.
Yes. I don't know how you enter that, but I'm sure you'll figure that out. Okay. I think we're up to 12.
Yes.
All right. That's they're giving you a lot of instructions here. So the the first property here is the natural log of A over B becomes the natural log of A minus the natural log of B. So the way that impacts it here, it's natural log of x to the fourth square root of y cubed minus the natural log of z to the fifth. Is that okay?
Yeah.
All right, the next thing we're going to do is the natural log of A times B becomes the natural log of A plus the natural log of B. That applies to the one on the left here. It becomes the natural log of x to the fourth plus the natural log of the square root of y cubed minus the natural log of z to the fifth. All right, so the other thing here is that this square root, you have to remember how to rewrite that. Square root is really 1/2 power. So this becomes y to the 3/2 power. You multiply the 3 times the 1/2, that's 3/2. Is that okay?
Yes.
And then for all of these, you can bring the exponent out in front. So the 4 comes out in front. The 3/2 comes out in front. And good luck entering this. I have no idea how they want it. I know it says no spaces, no decimals. I guess I'd probably enter it exactly the way it's written here, although there really should be. I mean, yeah, I guess I would enter it like this without any parentheses or decimals or anything like that. All right, so let me know when we go on to the next one.
Okay, I'm ready.
Be a little tight here actually to finish. But so we do the same thing here. We just do it in reverse order. However, log base b of 1 is always 0. So this one right here, this ends up being 0 because log base 10 of 1 is 0. 4 times 0 is 0. So just a teacher being difficult here with you, but 1/2 log base 10, 9 minus 2 log base 10 of 2. All right, so the next thing here is that you bring the exponent up for all of them. And so this becomes x to the fifth, 9 to the 1/2, 2 to the 2. And the reason I'm not writing the logs is because we're going to simplify. The 1/2 is the square root of 9, which is 3. This is 4. So it's log base 10 x to the fifth plus log base 10 of 3 minus log base 10 of 4. All right, now this is where we're going to go to our final answer. So the way this works is if it's positive, it goes on the top. If it's negative, it goes on the bottom. So x to the fifth on top with a 3, and then 4 goes on the bottom like that. So in terms of how you enter it in that box, it would be 3x 5/4 in your box there. It's like that's what they want. Let me know we can move on to the next.
I'm ready.
All right, next one's, it's really easy if you have a calculator. If you don't, you're really stuck. You really want the 4 and the 8 to somehow work together. And they look like 4 times 2, but it's got to be exponents. So the thing to remember here is that 8 is really the square root of 64, which, I mean, I don't know how you would know this, which is really 64 to the 1/2. And then 64 is really 4 to the third power. So this 64 becomes 4 to the power of 3 to the 1/2 power, which means that you multiply them. It's really 4 to the 3/2 power. So this original problem here, we kind of work it out now where it's like, okay, instead of 8 is really 4 to the 3/2 power. Like you know, you never thought to do anything like that, but that's what it is. So then the exponent comes out in front. 3/2 log base 4 of 4. This part is 1, so it's 3/2 times 1, which is 3/2. Any questions on this?
No,
We
I
don't have
got
much time, so make sure we get it all in. Okay, so the graph of this e to the minus x plus 1 minus 8 ends up looking like this. 0, 1. Okay, it's looking like that. This is y equals 8. So the domain of this is always minus infinity to infinity. The range is from the horizontal asymptote to positive infinity. Even though it goes here, it goes up forever. And then I've already listed the asymptote here. It's always the vertical shift. Maybe another lesson we can spend a little more time on that. Sorry, there's a little bit rushed at the end, but
that's
assume we
always
wanted to get through everything. All right, just double check. We got 2 minutes left. Double check, see if you got all the answers down, everything entered in. Any questions on what we did? Any entries that we need to fill out? Well, might be good to look at one more time.
submit it really quick. Okay. Yeah, I
Everything
got
look
them all
good?
right.
All right,
Yeah.
fantastic. Okay.